Today, we're diving into the massive, hidden energy costs behind every click and query. But here's the fascinating part. The very same AI that's driving this crazy energy demand, it might just hold the key to fixing it.
Think about it. Every single time you ask an AI a question, or, just save a file to the cloud, all of these digital actions, they feel completely weightless, almost magical. But here's the thing, behind every single one of those clicks, there's a very real physical place, a massive humming building just packed with powerful computers. Yep, you're using a data center.
And because these buildings are totally out of sight, we almost never think about the tremendous amount of power they need to run. So what is the energy bill for the cloud anyway?
All right, let's talk about the cloud's energy bill. And spoiler alert, the numbers are pretty staggering.
To really get your head around the scale of this, just look at the investment. Goldman Sachs is projecting about $8 trillion, with a T, is going to be flowing into AI, chips, and, you guessed it, the power supply for these data centers. A huge chunk of that cash isn't even for making AI smarter, it's just to keep the lights on.
So where's all that electricity going? Well, inside every single server, you've got the brain, the CPU, that's doing all the heavy lifting. Then you've got memory, storage, all the networking gear, and every single piece is constantly drawing power. Now multiply that by thousands of servers in just one building, and you start to see how that energy bill gets so huge.
Okay, so this presents a massive challenge, right? How do you make these data centers way more efficient without, compromising the privacy of all the data they're crunching? Well, the answer lies in this really clever approach called federated learning.
The core idea here is honestly a game changer. Instead of pulling everyone's sensitive data into one giant, central, and kind of vulnerable location, federated learning trains the AI models locally, right where the data already is. This is huge, not just for privacy, but as we're about to see, for energy efficiency too.
Okay, so here's a great way to think about how it works. Imagine each local server is a doctor. They learn from their own patient's data, right? But they would never ever share confidential medical records. Instead, what they do is share generalized findings. Those are the model updates with a central hospital, which is our global server. So this global server combines all these anonymous insights to get way smarter, but it never ever sees the raw private data from any single patient. Pretty cool, huh?
So, now that the learning can happen privately and securely, the system can do something else that's really smart. It can intelligently shuffle tasks between servers to save a massive amount of energy. It's like a smart workload shuffle.
And this whole process is basically a constant four-step dance. First, the system identifies any server that's being overworked, drawing too much power. Second, it finds a server that's underutilized and has some spare capacity. Third, and this is where the AI magic happens, it uses that global model to predict the exact power savings of making a move. And finally, if the numbers look good, bam, it seamlessly shifts part of the workload over.
Okay, so that's the theory. Sounds great on paper, right? But did it actually work? Let's dive into the data from the simulation and find out.
All right, so the researchers put this system to the test. They ran it across 100 different servers, and the results? Well, they tell a really compelling story about efficiency. Check this out. On the left, you can see the initial power distribution was just all over the map. Some servers were totally maxed out, while others were just sitting there, barely doing anything. But look at the final distribution, the one in green. It's all clustered tightly in the middle. The system balanced the load, smoothing out all those inefficient peaks and valleys. And you see the exact same pattern over on the right with memory usage. It's a much more stable, much more balanced system.
And here's what's really cool. The system learned. This graph here shows what's called the global model loss. Just think of it as the AI's error rate. You can see that with each training cycle, or epoch, that error line just keeps dropping. That means the AI was getting better and better at making smarter predictions about how to shuffle those workloads to save the most power.
This table gives us a perfect little micro example of what's happening. So server 4 was running really hot, using almost 227 watts. The system then shifted some of its work over to the underutilized server 69. Now, you probably expect server 4's power to drop and server 69's to go up, right? That makes sense. But look what happened. They both went down. This shows the system isn't just dumping work from one place to another. It's actually finding a more efficient state for the entire network. It saved over 23 watts in just that single move. That's incredible.
So what does this all mean for the bigger picture? This is more than just a clever trick for one data center. This could be a blueprint for a much more sustainable internet.
So what you end up with is a system that has two huge benefits. First, and obviously, it saves a significant amount of electricity. But second, by preventing servers from getting overloaded in the first place, it also makes the whole network more resilient. And that means less hardware failure, less downtime, and a more reliable internet for all of us.
So, if you remember one thing, it's this. By using federated learning to intelligently balance workloads, we can slash power consumption in data centers and prevent server burnout, all while keeping our data private. It's a really clear path toward building the AI-powered future in a much more sustainable way. And that leaves us with a really powerful question. We tend to think of AI as this massive energy problem, but what if it's also the solution? This research shows that we can use AI's intelligence not just to answer our questions or generate images, but to build a smarter, more efficient, and ultimately greener internet. The intelligence is already there, we just have to point it at the right problems.